Okay, Algebra 1, I've done 3 examples here for the last assignment of this 9 weeks. You are going to be solving by substitution on the systems of equations. So the first thing that you look at on every problem is to see whether you have something y equals or something x equals. In this case, we know that in the first equation it tells us y equals negative 2x plus 3. So what we're going to do is we're going to take that negative 2x plus 3 and we're going to substitute it in for the y in the second equation. So it looks like this. You write 3x minus 2 and then put a parentheses, and instead of having that y, we now have the negative 2x plus 3 and then equals 8 to finish that equation. Now you'll notice that all that's left are x's. There's no more y's, so we can distribute our negative 2 and then solve for x. So I'm going to distribute right here and get 3x, and negative 2 times negative 2x is positive 4x. And then I'm going to do negative 2 times positive 3 to get negative 6 equals 8. Then I'm going to combine my like terms, which are here. I have 7x minus 6 equals 8. Now I'll add 6 to both sides, and I get 7x equals 14. If I divide both sides by 7, I end up with x equals 2. Now remember, that is not your entire solution when you're doing system of equations. You need to have an ordered pair. So we're going to take the 2 and I'm going to plug it back into either equation. I can either use this one or this one. But remember, sometimes it's easier if you look for the one that will be faster. And since we are going to be solving for y, and we already know that y equals this, if I use this top equation and plug it in, so I know x equals 2, so I'm going to go up here and I'm going to substitute a 2 for the x right there. So that's where that goes, right there where that x is. And then plus 3, and now I can solve for y. Y equals negative 2 times 2 is negative 4 plus 3, and negative 4 plus 3 is negative 1. So I have that, and I have that. I'm going to write that as an ordered pair. Remember, your first number is always your x, and x is 2, y is negative 1. So that is the solution on that one. Let's look at the next example. So again, the first thing we do is we look to see if either equation has y equals or x equals. And in this example, the second equation tells us that x equals 3y plus 1. So I'm going to take this 3y plus 1 and I'm going to put it where the x is in the top equation this time. So I'm going to write this 2 parentheses. I'm going to put 3y plus 1 where that x is. Then continue that top equation. Minus 4y equals negative 10. And hang on just a second, I'm getting a phone call. Okay, I'm back. Alright, so now what we're going to do is we're going to distribute the 2 to the parentheses. So I'm going to multiply the 2 times my 3y and then the 2 times the 1. And I end up with 6y plus 2. And then I bring the rest down, minus 4y equals negative 10. Now I combine the like terms. This is kind of hard to see. Let me change back to blue. Now I have a voicemail. Sorry about that. Okay, so 6y minus 4y is 2y. So I'm going to write 2y plus 2 equals negative 10. Then I'll subtract 2 from both sides, and I end up with 2y equals negative 12. If I divide both sides by 2, I will now have y equals negative 6. So this time I know what y equals. Y equals negative 6. So I'm going to come back and I can put it in either one of these equations, but I'm going to choose the bottom one since I already know that I've already got the x by itself on one side. Just makes it a little bit easier. So I'm going to write x equals 3 times negative 6. So I'm plugging in what I got for y into this other equation so I can solve for x, and then the plus 1 at the end. And 3 times negative 6 is negative 18 plus 1. So x equals negative 17. It's kind of a weird number, but that's okay. We're going to put this into an order pair. Remember, the x number is always first, so it goes negative 17, negative 6. So this here is the answer. Okay, so there's that. Let's look at the last example. So this time, remember, the first thing you look for is to see if you have x equals or y equals, and we don't have that in either one of these. So then we have to look to see where can we solve for x or y in either equation. And I have a y by itself up here and an x by itself down here, but I'm going to go ahead and solve for this y because this y is also positive. Makes it just a little bit easier. So if I bring this equation down, I can now, if I move this negative 2x, or move the 2x over to this side, I'm going to go ahead and put that negative 2x in front of the negative 5. It doesn't matter either way on these because you don't have to have it in slope-intercept form. We're just trying to solve for y. So now I know what y equals. Since I know what y equals, I'm going to take that, I'm going to plug it into the other equation where the y is, right there. So I'm going to have negative x minus 3, and then I'm going to put what I just found out what y is in there. So negative 2x minus 5 equals 10. And then I'll solve this like I've done the others. So I need to distribute my negative 3 to both things in parentheses, making sure I carry the negative with it. So I'll have negative 6. Negative 3 times negative 2x is positive 6x. Negative 3 times negative 5 is positive 15. So I end up with that. And then I combine my like terms, and negative x plus 6x is 5x. 5x plus 15 equals 10. Then I'm going to subtract 15 from both sides, and I get 5x. Oops, that makes those go away. Let me fix this x. I get 5x equals negative 5. Then I'm going to divide both sides by 5, and I get x equals negative 1. Okay, so now I'm going to take that and I can plug it back into either of my equations right here, but I can also use the equation I found when I did that. So I'm going to go ahead and use this one this time because my y is already by itself. So my x is negative 1, and that is, I'm going to bring that one down here, negative 2x minus 5, because the x is negative 1 in all of these, in all of these problems, in everything from here, in both of these, in this system. In every equation I write with an x in it, I now know that x is equal to negative 1. So I can take this one and go negative 2 times negative 1 minus 5. And negative 2 times negative 1 is 2, and 2 minus 5 is negative 3. So now my x is negative 1, and my y is negative 3, and that's the answer. So the only time it matters which one you put it in is when you're starting out. So whenever, like I solved for negative 2x minus 5, since I used that top equation to get this one right here, I have to put in what I got for y into the other equation. So that's the only time it matters which one you use. Once you have what one of your letters equals, you can plug it into either equation. I hope that makes sense. If you have any questions, be sure to let me know. I'll be happy to help. See you guys tomorrow.